In this video, we're going over the bottom-up approach of interleaving strings. Let's go over the thought process. Let's convert the top-down memorization approach to a bottom-up approach. Where do we start? In the memorization approach, we have cached I and j with can't interleave. This means we can create a 2D matrix can't interleave to keep track if we can interleave the two strings for all possible combinations of I and j. Now, what are the default values inside can't interleave? When I and j are both out of bound, this means we have checked through all of the characters, which means S1 and S2 can interleave into S3. S1 and S2 can interleave into S3. This means can't interleave I and j will be equal to true. Let's go over the pseudocode. So let's first validate the input parameter. If the sum of the lengths of S1 and S2 is equal to S3, it's not equal to S3, then we can just return false because we cannot interleave the two strings. Now we're going to create a 2D Boolean matrix can interleave to keep track if we can interleave the two strings for all combinations of I and j. Now we want to iterate through the indices from S1.length to 0, which will denote it as I, and then we'll iterate through the indices from S2.length to 0, which will be j. If I and j are both out of bound, that means we can set can't interleave to true. Can't interleave I and j to true. Then we can continue to the next iteration. Now, if I is not out of bound and the current character at I inside S1 at index I is equal to the current character inside S3 at index I plus j, this means we can check if we can interleave the two strings by moving I forward. So if can't interleave I plus 1, that means we're moving I forward, is true, then we're going to set the current can't interleave to true also, because we're able to interleave at I and j, I plus 1, this means we move I forward. Then we'll set can't interleave to true, then we can continue to the next iteration. Now we'll do something similar for the j. So if j is not out of bound, and the current character inside S2 at index j is equal to the current character inside S3 at index j I plus j, this means we can check if we can interleave the strings by moving j forward. So if we can interleave the strings by moving j forward, we're going to set the current can't interleave to true also. Then we continue to the next iteration. Notice we can return can't interleave starting from indices 0, 0, because we want to start our two pointers from 0, 0. Let's go over the time and space complexity. So the time complexity is O of m times n, where mn are the length of the two input strings. This is the nested for loop. And our space complexity is also m times n, This is because of our can't interleave matrix. Let's go over to code. So we're first going to validate the input parameter. So if s1.length plus s2.length is not equal to s3.length, this means we cannot interleave the string, so we can just return false. And then we're going to create our matrix. Can't interleave is Boolean. The new Boolean s1.length plus 1 and s2.length plus 1. Now I'm going to iterate through the indices from s1.length to 0, denoted as I. Then we iterate through the indices from s2.length to 0, denoted as j. If I is out of bound and j is out of bound, this means we have successfully interleaved the two strings by checking off the characters. If j is out of bound, then we can set the current can't interleave to true. Then we can continue to the next iteration. Now we'll first check if j is if I is not out of bound and the current character at I is equal to the current character at I plus j inside S3, then we can check if we can interleave the strings by moving I forward. So if can't interleave by moving I forward, so I plus 1, then we will set the current can't interleave to true also, and we can continue in the next iteration. Now I'm going to perform something similar for the j pointer. So we'll check if j is not out of bound and the current character inside S2 at index j is equal to the character inside S3 at I plus j, then we can check if we can interleave by moving j forward. And if it's true, we will set the currents I and j to true, and we'll continue in the next iteration. After all the iterations, we can return the results if we can interleave starting from the two initial pointers 0 and 0. Let me know if any questions in the comment section below.